let others join. So we'll start the class after 1 minute. So this we have discussed in the last class, astable multivibrator. The output of the astable multivibrator will change from plus VSAT to minus VSAT back to plus VSAT. A DC I am applying, but I am going to get a square wave. Last class you people have copied some of the information from this slide, and also I asked you people to copy down this in the last class, and most of you copied this particular astable multivibrator circuit as well as a waveform. So hope all of you copied this circuit diagram. Shall I go to the next? You can type yes in the chat box so that I can go to the next. Otherwise I'll wait for a few seconds. Those who have not copied completely, they can copy down. Okay, Rohit is telling yes sir. Then we can go to the next. Majority are saying yes. Thank you. Now try to understand. The concept is very simple. Thank you everybody. Based on a VID, some voltage will be there, a VID. Please try to observe carefully. I have made a different color so that you can identify very easily. No need to search. Based on the VID, as we have positive feedback here, either op amp will be a plus VSAT or minus V saturation. Initially, charge of the capacitor is 0. Let us consider capacitor charge is 0. Therefore, V2 will be 0. V1 is very small voltage, but depending upon the output, VID will be equal to V1. Because this is 0, hence I can say VID is nothing but V1 only. Just take a few seconds and copy down 1 or 2 lines from this. Initially capacitor voltage is equal to 0, that you copy down, and therefore V2 is equal to 0. V1 is a very small voltage. Because of this V1 and V2, VID will be equal to small voltage V1. If you note 1 or 2 lines, it is more than enough. Then we will go to the working. How actually I will get a square wave from this? That we are going to discuss now. Let me go to the next. Only note down VC equal to 0, V2 equal to 0, V1 equal to a small voltage, therefore VID equal to V1. So gain is high and the output will go to the saturation. Because of very high gain, because of this positive feedback, output will go to the saturation. Let us assume, observe carefully, now it is a plus V saturation. Because of positive feedback, either it will be plus V sat or either it will be a minus V saturation. Observe carefully. Now let us assume it is a V saturation. Now when it is a V saturation, now capacitor starts charging through R. This capacitor will start charging through R, whatever the plus VSAT is there. How it will charge, and observe carefully. C starts charging. Observe carefully. It starts from 0 actually. First time I am showing in between the waveform. So you copy down a one line that because of gain is very high, the C output will be say positive saturation, and C starts charging through the R. Observe it. So now C starts charging. It is increasing. When it reaches, this voltage is V1. So when it reaches V1, a little more than V1, then what will happen? Observe here. C starts charging through R resistor. Now this voltage becomes say V1 a little more than V1. That time output will go to the minus V saturation. Why? This becomes positive and this is an inverting terminal. Hence, this will go to the minus V saturation. Observe carefully this. And because of this V2 becomes more compared to V1, output will go to the minus V saturation. This you have to understand. And now output as shown, it is a negative saturation. Now V1 becomes a negative. Why? V1 becomes negative because this is a minus Vsat. A part of minus Vsat only, it is divided among R1 and R2. Therefore, this V1 will become a negative voltage. So, observe this. This becomes a negative saturation. Therefore, V1 becomes a negative voltage. I'll pause here. I'll wait for you to copy. Take a minute, copy down this. Copy down this. Output remains a negative. Capacitor discharges and then recharges to the negative voltage. This is shown in the graph. Try to understand this. Now again, when this minus V2 becomes greater than minus 1, then again V0 becomes a plus V saturation and capacitor discharges, then recharges towards the positive. Try to understand this. Now it will charge towards the positive. So try to understand, and this will continue. Again it will become a minus Vsat. Again it will become plus Vsat output, and capacitor will charge, discharge, charge, discharge. So this will continue, and V1 voltage is given by R1 by R1 plus R2 into Vsat, and time period of this one cycle is given by 2RC ln of 2R1 plus R2 by R2. Copy down this, and I'll wait for you to copy. Now I want to convert whatever the square wave I am getting at the op-amp output to a triangular wave. How to get a triangular wave? Don't say this is a triangular, right? It may look like a triangular, but it is a charging and discharging. It's not a perfect triangular wave. I want to get a triangular wave. What circuit I can add here? Take a minute and type your answer in the chat box. Thanks for your answers. Every individual student has mentioned integrator can be used to convert a square wave to a triangular wave. Whatever you have told just now, the same thing I am going to show you. Now what I do with this, I will connect one integrator so that I can convert the square wave into a triangular, and we have already discussed integrator. A video is uploaded in the YouTube. In the class also, all of you know, lab we have conducted the experiment, and this is the way how we can convert now a square wave into a triangular, and this complete circuit I can say it will generate a triangular wave. Take a 1 minute, you can copy down and try to understand. I'll wait you people to copy. All of you know the frequency modulation. What is the frequency modulation? What is changing there actually? In accordance with what it's changing? Just type your answer in the chat box. I'll be happy to read your name. What do you mean by frequency modulation? Okay, majority are typing. Frequency is changing with respect to, okay. Frequency changes, correct. Now, in oscillators, frequency is determined by the RNC value, whatever we have discussed so far. In some applications, for example, just now asked in the frequency modulation, what is the FM? We have spent a little time to discuss that. There, the modulation, frequency modulation, frequency need to be controlled by the input voltage, modulating signal voltage. This is done with a voltage controlled oscillator. It's basically an oscillator, but voltage controlled. Oscillations will be controlled by the input voltage what you are applying. So one simplest example is NE566 voltage controlled oscillator. Copy down this, and I'll wait for you people to copy. Take a minute. This is a block diagram of a voltage controlled oscillator. It provides a square wave and a triangular wave as a function of an input voltage. In lab sometimes we use this IC also. Just copy down the block diagrams and try to understand the blocks. I'll wait for you to copy this. We have a external R1, we have a C1. This is the modulating input or whatever the voltage you are giving, based on that the frequency you are going to get from this particular IC. Frequency of oscillations determined by the R1 and C1, what we are connecting external R1 and C1, and whatever the input voltage you are applying, based on that you will get here the frequencies. And triangular wave you will get due to the charging and discharging of this particular C1 capacitor, and amplitude of a triangular usually will get 2.4 volts, and a square wave what you are getting here, amplitude will be equal to nearly 5.4 volts. And R1 C1 decides the free running frequency. Free running means when you are not giving anything here, what frequency you are going to get determined by the R1 and C1. Copy down. VC is set by R2 and R4. This is R2 and R4, and R2 and R3. While typing, I think I have typed R4. It is R3, and frequency is given by 2 plus V minus VC divided by R1 C1 plus V, where R1 should be in between 20K and 2K, and this VCO is also used in the ECG also. Okay, copy down this and try to understand. We have completed this unit 4. Active filters we have discussed. Active filters, passive filters we have discussed. First order, second order, low pass and high pass butterworth filter. The design we have discussed. Frequency scaling we have discussed. Phase shift oscillator, circuit diagram, waveform. Before going to the phase shift oscillator, we have discussed oscillator, oscillations, underdamped, damped. Lot of discussion we had done, even though in between, even though it is not there in the syllabus, we have spent a lot of time to discuss that. And then we have discussed the Wien bridge oscillator, square wave and triangular wave generators we have discussed. Just now we have discussed a voltage controller oscillator. So just revise it. Take a minute or two. If you feel difficulty, you can type. We'll have a discussion. So I'll conclude today's class. And this is the end of the unit 4. I'll be here for another 5 minutes. If anybody is interested to interact with me, please you can unmute or you can type in the chat box. Thank you. Take care. Be safe. Bye.